So here we have a little more advanced problem where the instructions tell us to graph the solution to the following system of inequalities. Then give the coordinates of one point in the solution set. So starting with a system, the first thing that we want to do in terms of solve by graphing, it would be similar if we had systems of equations. The first step we want to do, and I'll write it right here, first step is to put it in y equals mx plus b form. Y equals mx plus b form. We already have one of the inequalities in y equals mx plus b form, or is in terms of inequalities greater than or less than. The second inequality is what we want to put in y equals mx plus b form. And then we would want to graph and find the solution set. And then we can check by plugging a coordinate back in. So the first thing we want to do here is put the second equation, or inequality, excuse me, in y equals mx plus b form. So we can go ahead and do that here. We would use opposite operations to subtract 4x from both sides, giving us 3y is less than negative 4x plus 3. And then we would divide everything by 3 in order to isolate y. Y is less than negative 4/3 x. And then 3 divided by 3 is plus 1. So now we have our two inequalities in the y equals mx plus b form, where we can easily recognize our y-intercept and our slope of the second part, and our y-intercept and our slope of the first part. And if we recall back to the number of solutions in a system, we remember that when our slopes are the same, we need to then compare our y-intercepts. And if our y-intercepts are different, it tells us that there could be no solutions to that set if they were equations. If they are equations, because it's telling us what kind of lines they are. So we see that they're going to be parallel lines, and if this were a system of equations, we would have no solution. But seeing that they're inequalities and we would have some shading to do, there might still be a solution to this system. So let's go ahead and look at the first one here. We'll go ahead and graph this top one in red, and we'll do the bottom one here in black. So we would start with our y-intercept, which would be the coordinate 0, negative 5. So we would come from the origin and we would come down 1, 2, 3, 4, and 5. That's our y-intercept. And then we would use our slope, negative 4 over positive 3, or we could put the negative to the 3 and say positive 4 over negative 3. Either one works. We would start with a negative 4, so down 1, 2, 3, and 4, and then positive 1, 2, and 3 is another point on that line. And then if we were to apply the negative to the bottom, we would say positive 1, 2, 3, and 4, up, or to the left, negative 1, 2, and 3, and up 1, 2, 3, 4, 1, 2, 3, and we would just continue to do that pattern. 1, 2, 3. And then these are the points on the line. Now the next thing that we need to remember is when we have inequalities, if we have a less than or greater than sign, that the inequality is going to be a dashed line, because the line itself is not part of the solution set. Y is either greater than or less than that line. The y values will be. So we would have a dashed line at this point. because the line itself is not included. Now, we're not quite done with this yet because it says y is greater than the negative 4/3 x minus 5. So this is telling us that our y values are going to be greater than the indicated line and not including. So all of our y values, remember y is our vertical, right, not our horizontal movement. So our y values, if we look on the line, all our y values would be greater than or would be above the line. So the solutions would be have a open circle on the line and would include all the y values at any point x, would be an open circle and include all the y values above it. Open circle, everything above that line because the y values are greater than that point. Now let's go ahead and look at our second inequality. Y is less than negative 4/3 x plus 1. We know again by the slopes and the y-intercepts that they're going to be parallel lines. And we start at our y-intercept of 0, 1. So we will start at the origin, go up 1, and that's our point. And we have the same slope. So we would go down 1, 2, 3, 4, to the right 1, 2, and 3, down 1, 2, 3, 4, 1, 2, and 3. Or we could apply it to the bottom, go up 1, 2, 3, 4, over 1, 2, and 3, up 1, 2, 3, 4, 1, 2, and 3. And I told you that I was going to do this in black, so I'll switch to black. Again, we see that it's a less than sign, not equal to, so we will have a dashed line. We have a dashed line at this point. And remember, if we have a less than or equal to or greater than or equal to, we would have a solid line because the line itself would be included in the solution point, or in the solution set, excuse me. So in this inequality, we see that, and we're almost done, we have a dashed line. However, all the y values are less than the dashed line. Less than meaning if we're talking vertical, they would land below the line. So at any x value, let's say we went over 1 and up to the y value on the line, it would not include that y value, but it would include everything below the line. So anything on the line, x value, did not include the y value on the line, but everything below it. And I think you probably see a pattern here. So everything below. So in order for this to be in the solution set, now we see that this line here, this first part, would include everything. If we were to just, if we were just interested in this inequality here, we would shade everything above the line, including this section over here. But we're only interested in the solutions that make both statements true, or are solutions for both inequalities. So we see that it's going to be only the region in between the lines. So we could shade in between the lines. And I'll go ahead and do that in blue so that it's a little easier to see. So we would shade everything in between the lines to not include the lines. We would keep those dashed lines. Now in order to check and to give a coordinate of a point in the solution set, we could choose any of the points in the shaded region and check our work by plugging it back into this system. So the easiest, of course, is we see that 0, 0 right here is in the shaded region. So we can check the solution 0, 0, and we would need to plug it into both because it's a system. So if my system looks like this, y is greater than negative 4/3 x minus 5, and y is less than negative 4/3 x plus 1. When we plug 0 in for y and 0 in for x, here we would get 0 is greater than 0 times negative 4/3 is 0, minus 5 is negative 5. And we see that 0 is greater than negative 5. That checks out. And then 0, 0 here again, we would plug in 0 for y is less than negative 4/3 times 0 is going to be 0, add 1, and we get 1 is greater than 0, which also checks. And we are done.